we're going to be predicting precipitation using thermodynamics. So this is something that you've already been exposed to, but we're going to talk about a new way to think about this problem. So I just want to remind you guys that we can predict precipitation using the solubility rules, but if you're given just the Ksp, remember that we talked about the difference between Q and Ksp. So Q is the ion product expression or the reaction quotient, whereas Ksp is the solubility product constant. So remember that K doesn't change, but Q can change depending upon what point in the reaction, how far the reaction has progressed. And remember that if Q is less than K, the reaction will proceed to the products, and if Q is greater than K, it'll go towards the reactants. All right, for precipitation reactions, you can selectively take advantage of differences in your solubility product equilibrium constant for different types of reactions. So for instance, the Ksp for lead iodide is much greater than the Ksp for mercury iodide. So what this is saying is this is much less soluble, mercury iodide is much less soluble than lead iodide. So you could selectively precipitate, this will precipitate out at a lower concentration than your lead iodide. So you can selectively precipitate out things with different solubilities. But I wanted to show you how we can predict precipitation. So this is similar to the practice problem that you guys did in class, but I just wanted to show you how you could solve it from a different perspective using your Q and K. Our calcium nitrate, which we know is soluble because it's a nitrate, and we have our sodium fluoride, which we know is soluble because there's sodium. And this is going to react calcium fluoride, which is a solid, plus our sodium nitrate. All right, so if we were to write a net ionic equation, and this is what many of you wanted to do in class, then we would show that we would have, oh, and this needs to be balanced, calcium 2 plus 2F minus going to calcium fluoride, which is a solid. Okay, so if you guys notice, this is just the reverse of your Ksp expression. So we could just write it as our Ksp expression. So let's just rewrite that. So we have calcium fluoride, put Ksp up here, going to calcium 2 plus 2F minus. Okay, so Q is also equal to this. This is our equilibrium expression. This is our reaction quotient. So if Q is less than K, then we can say that the reaction, if Q is less than K, our reaction will go towards our products. But if Q is greater than K, then our reaction will go towards our reactants. So we need to calculate Q to be able to predict whether this precipitation will happen. So what that means is we need to calculate our initial concentrations of our calcium and our fluoride. So we do that just the way that we did it previously. So first we need to calculate the concentration of our calcium 2 plus. So we know that this is a soluble salt so that it completely dissociates, and it's a 1-to-1 ratio between calcium 2 plus and calcium nitrate. So to figure out the number of moles, we have the volume and the molarity, and we have our total volume. After we mix it, it's going to be 0.1 plus 0.2 liters, which is equal to 0.3 liters. Okay? So to calculate our number of moles, we're going to just do our molarity times our volume, which is going to be equal to 0.3 moles per liter times 0.1 liters. But then we need to divide this by, so this is going to be equal to 0.03 moles. But to find our concentration of calcium 2+, we're going to take that number of moles, 0.03, and divide it by our new volume, which is 0.3 liters. So we get 0.1 molar. And then we'll do the same thing for sodium fluoride, and it's also a 1-to-1 ratio between sodium fluoride and fluoride. So we'll just do it right here. 0.06 moles per liter times 0.2 liters, and divide that all by our new volume, which is 0.3 liters, and we get that our concentration of F minus is equal to 0.04 molar. That's our concentration of our F minus. All right, so now that we've calculated the concentrations, we can calculate Q. So our reaction quotient is just going to be equal to our calcium concentration, which is 0.1, times our fluoride concentration squared, which is going to be 0.04 squared. And if we calculate that, we get that Q is equal to 1.6 times 10 to the negative 4th. So Q is 1.6 times 10 to the negative 4th. K is 3.2 times 10 to the negative 11th. So we can see that Q is much less than K. So that means that our reaction will proceed to the left. So if we're proceeding to the left, that means that our precipitate will form. All right, so all of this is just to show you how to predict whether or not a precipitate will form. And you could have, qualitatively made this prediction because the forward reaction is going to be non-spontaneous, but the reverse reaction will be spontaneous. So, but this is how you can use Q's, comparing your Q value with your equilibrium constant to predict precipitation.